Hello, welcome everybody here with another Tech 90. I am your host, JD, with the residential department and also trainer. Today I have with me, I have Greg and Jesus, if you guys want to say hi.
Hi, Greg Bruntz. I'm the National Technical Support Specialist for Commercial Equipment here at GREE.
Hey guys, it's Jesus Fraga. I'm the technical product manager here at GREE.
All right, thank you guys. And today we'll be talking about proper board installation proper board replacement, I should say, on the GREE Mini-Splits and the FLEXX R32 systems. We're going to cover the correct procedures, recommended tools, practical tips to help prevent repeat failures and callbacks. Here's a rundown of what to expect on the Tech 90 for the first few minutes. First, we'll run a video from a previous training on replacing a board on a FLEXX system. Then we'll come back and chat with you live and answer any questions up to that point. Then we'll continue with a second video on replacing a board on a GREE Mini-Split. Finally, we'll finish with another Q&A session. So don't forget the questions. If you have questions or comments at any time during the broadcast, use the question mark icon to the right of the screen and send them our way. We'll answer any relevant questions until we run out of time. So with that said, let's get started. But first, why did we choose this topic to highlight, Greg?
Well, the biggest reason I think is, just proper procedures to board replacement. You and I have both taken these calls. I believe Jesus has as well, where a board's been replaced. Now the new board's damaged. So I think it's just important that we make sure everybody knows the proper procedure to replacing these boards. When you have air-cooled inverter drive boards, that thermal paste is critical. And then sometimes some of the boards can be finicky too. In other words, you can't switch up, like, even though it's 230 volts. Sometimes the guys will be like, well, 230 volts is 230 volts, and they'll reverse the two hot wires coming into the board. We've seen and found that ourselves that doesn't always work. So any little nuance that we can pass on, but also along with giving proper procedures to replacing the board, I think it goes a long ways into allowing these guys to go out and do a board replacement and only have to do it once.
Yep, and getting all the screws in, or using the correct screws. Don't use sheet metal screws like the one guy.
Yeah, taking the technical support calls for techs out there in the field. You gain some. Let's see how I gotta put this. You gain some confidence whenever you know for a fact that you've done it before. Obviously either in a lab setting or like all of us here in the field. We've been those techs in the field, but I guess what I'm getting at is, it's great to feel the confidence to be able to tell the tech over the phone, like, hey, I understand this looks tedious, but just know that it can be done. And, that obviously the videos that we're about to show, are the correct techniques and procedures that any tech would need to take to go ahead and replace, any GREE FLEXX or GREE Mini-Split board. So I think today's Tech 90 is going to be great.
The other thing I want to state real quick, JD, is there seems to be a misconception with some guys that watch our broadcasts and stuff, and they look at it as, it's easy to sit behind a desk and tell somebody else how to do it. I want to debunk that, in that every single one of us have came from the field, and this is information that we feel is important enough that if I was still in the field doing this and didn't know this stuff, I would absolutely be appreciative as be able to see a video to know the proper procedures to replacing a board. So
absolutely,
I've got a number of years of service behind me, and things change, and this whole mini split world has blown up across the United States in the last probably 10 years. So, your procedures that you do in a normal unitary product with just a contactor and a capacitor is not the same as working on an inverter driven unit. So, proper procedures to make sure we do the job and do it the first time and do it right the first time, I think, is extremely important. So,
absolutely.
Greg, I was thinking about something earlier. The amount of experience that Greg has is literally about the age that I am. So
That's true.
I just wanted to point that out. It's Greg has been a big help for me in my career for sure.
Absolutely, me
too.
JD.
Yeah, he sure has for me too.
Especially with these, me feel old, guys.
we're just
All
messing
right.
with you, man.
It's all good.
All right. All right. Well, with that said, let's go ahead and roll that first clip.
All right, so what we're going to do now is we're going to start with taking this board, the whole electric box assembly out of here. So part of the reason why I wanted to show this is because, and not necessarily on this machine, but in quite a few of the GREE Mini-Splits, and I've taken the calls myself, where technicians have tried to replace this board and they're doing it without removing the electric box assembly when the board is installed vertically, just like in this unit right here.
Yeah.
And that's where we want to show you that in order to do a board replacement in here, they need to pull the whole electric box assembly because they're not going to be able to facilitate getting the board changed properly with the electric box assembly in here. They don't have enough clearance here, and you will also see that on this other unit too, that they're kidding themselves trying to do it when it's vertical like this.
And it takes less time to take the electric box assembly out and put it on a bench, just like we were talking about earlier, to sit it out and do what we need to do, and we'll demonstrate that, which shouldn't take us too long actually.
Yep. So we'll go ahead and get this popped out of here. And
so as you can see, it's loose. We just need to get the wires
we're
loose.
going to get these wires off. And again, best thing to do, the wiring diagram shows it, but just take a quick picture. Then verify your picture. Make sure you're going to be able to read it when you need it, which I can.
Notice on these
But I also
Stay-cons.
realized with this one here, you could just take these two screws out right here and leave the
yeah,
wires
you could,
connected.
couldn't you? Let's do that this time since we didn't do that last time.
And then your ground and your wires all stay connected because we don't really need to unhook it there.
But if your electrical was connected to this unit as it were
You
installed,
got to take that one
then
too.
you would
You got to take that.
find it a lot easier just to take the Stay-Con off of there compared to what we're doing. So technically, it's just one screw here taking the entire block
Oh yeah, so we didn't even
off
need
of
to take
there.
them.
We
other
didn't
two
need to
screws
take
out.
those other two out.
See,
So
we're
I'm
like
gonna set this
we're
right
like
here.
auto mechanics. Take more apart than we need to.
Yeah. And
That's
then
great.
when you're done, if you don't have 3 screws left, then you haven't done the job right.
Pop this out. I believe we got 2 wiring harnesses here we're going to unplug. Yep. All right, so we got a couple
lose
plugs
it,
on this other
you
side.
replace
I'll
it.
let you get those.
So these 2 cables here come out from there. This assembly has a nice cover on the front of it to route the wires through. Keeps everything nice and clean. And also keeps your wires from rubbing on things that it shouldn't and shorting out.
Now the keepers on this we didn't have to remove because we've already done this once on this. We've already removed the keepers. So
Hence why we say no need to put them back.
all right, we
Because
got
if
the
anybody
compressor
ever has to do it again,
plug.
makes it a lot easier. That one is, there we go.
All right, so that board's out. Okay. Now we'll go to this other machine here in the corner to where we had the vacuum and everything showing there, and we'll pull this board out as well. Now I believe this one is actually inverted,
It is.
so you
So
wouldn't
this one
necessarily
you could
have
replace
to.
without
you could do
removing.
it, yeah. But this is the one that we have the replacement board for, so that's why we're going to show it to you on the bench. All we're doing is undoing cables, getting them off the top of the box, getting them off the side of the box.
All right, so I want to take a moment and talk about this compressor plug.
Okay.
So the compressor plug on this particular one, it has a plug in between the compressor and the board. So the wires are made into the control board. So there's no worry about getting the phase reversed when you're unplugging and plugging the compressor back up. But we have seen, and I've seen it, you've seen it, several instances where all it was, it had an H5 code, and the problem was that this plug was not seated properly. Now the one that you had, the wire or the terminal was
Something
not
was
pushed
wrong
all the way
with
up
the
into
wire into the Molex
the plug was damaged in some way.
So the technician on the job, what he ended up doing was just cut them off, cut the Molex plug out, butt spliced all together, and we had the unit up and running. It's convenient. It's convenient to have the plug to be able to just unplug it, but when you're in a pinch, you do what you got to do, right? So that's what he did.
All right, so in here we've got our EV plugs. They're color coded, so pretty easy to put them back where they go. Most of the Molex plugs that you'll see on here are going to be color coded or different sizes or different types.
Right.
So I haven't had one where I've gotten anything mixed up before, but I will say if you have a Stay-Con, like your incoming power, so your blue wire right here goes to a Stay-Con, your brown wire and your black wire goes to a Stay-Con. Blue is ACL, I believe. The brown ACL2, one's ACL1, one's ACL2, and then the other one's COM coming from over here on your terminal block. And those hook into the control board. If you unplug them, you want to make sure you take a picture of those, make sure you know where they go. It's pretty easy to see on the schematic where they go, which is I had one recently that and this was, we were talking earlier about the FLEXX where the H6 code is outdoor fan motor, and then on the Mini-Split, the H6 is indoor fan motor. Well, this technician got confused and replaced the outdoor control board for an H6. Didn't do him any good, but he did create himself a problem in that he reversed the ground in one of the power wires. Fortunately, it didn't mess anything up, but it wasn't working. Once we reversed those two wires, then it started working. He did end up with an H5 after
Which then it does make sense, because if you remember your 14.4 wire going to your indoor unit, you have 1, 2, and 3, 2 being your communication, 1 being part of that communication, 3 being power, 1's also power. So that communication circuit coming from that board to the 1 and 3 is actually critical so that it communicates properly. So reversing those 2 wires on the board is what ruins your communication.
Correct. And most of the time, you're not going to damage anything. But sometimes you could blow a fuse or damage the board itself. So, all right, there's those out of the way there. And then
I think we got to pop this. Did you get these wires off yet?
No.
Okay.
You want
Once
those?
you get them, no. Oh, you want to take them off here, or you going to take them off over there?
Take them off there.
Okay.
You just need to remove. Well, no, we don't have to remove those.
That's what I was going to say.
This is loose.
But they're caught on the box or something is what I'm getting at. I didn't get that screw out, so it's going to pop
It's okay.
out, just so you know. All right, cool.
And there it is.
Give me that screw.
Ah. The heat sink's kind of sharp, so you got to watch the edges.
Yep.
All right, now we're going to move over to our board replacement station we have set up.
Yep. All right. As I talked about in the inverter design and operation, I also talked about the P and N terminals. I talked about the DC plus and the DC minus. I use this in troubleshooting. I will have a guy on the phone, and I'm like, hey, let's check the DC bus. On the ones that the board is face down like this one is,
Yep.
we can pull that cover off, and I can have him take his meter leads right onto those 2 solder pots, right there where it says DC plus and DC minus. He's got to dig in just a little because there's silica on top of the board. but it gets
That's where the needle point connectors come in handy.
yeah, because they're sharp.
They're sharp, and all you have to do is just touch them. It'll
But
go
anyway,
right through that silicone.
I can have them check that DC bus, and right away that tells me whether or not that board was powered.
Yeah.
I mean, I may have a blown fuse on a filter board, and I have no DC bus, and just by quickly checking that, that also eliminated that fuse. Okay, so when I'm talking about that fuse, if we look at this filter board I have sitting here, so because on some of the older multi-18s and the multi-24, they have a separate filter board. And that fuse, if that fuse is blown, then you lose power to the main board, so you won't have any DC bus at all. If you look at that, the multi, like a multi-18, again, it'll be the CO, not the EO.
CO. This is the main board here and the filter board for a multi-CO. And I'll move this out of the way a little bit so you can see both of these. You'll notice that the current Gen 2 multi-18 that we just removed, there was no filter board in there. There's no separate filter board. It's built into the board. The C revision had a main board and a filter board.
But what I've actually had guys do on the phone then is if you look over, like if you're standing on the end of that unit where your 14-4 wires go into it, and they look at over the edge of the top of the painted panel, with that board, the main board's upside down in that unit. So if you kind of picture this is upside down in the unit. This filter board is mounted underneath of it somehow. And if you're looking over the painted edge of that panel and underneath this board, you'll see that fuse. And there's enough room in there, and I'm going to pull this back a little bit, that they can actually take their meter leads and go in there and take a voltage reading across that fuse. And if they're reading voltage, then that fuse is blown. So we know right then and there, that filter board is bad. So then the next thing that we will have them do, instead of just saying, all right, you got to get a filter board, what we will have them do is take alligator clips and a 5-amp fuse and just alligator clip across that fuse so we can get this board powered back up. So we can actually troubleshoot this board too to see if we actually have a main board failure
Or just a filter
or
board.
just a filter board failure. If I jump around this and that thing already clicks forward and the condenser fan motor comes on, the compressor's getting ready to start, then I know all they need to do is order a filter board. And then we've also had many calls, and I'm sure you've taken them as too, Daniel. They've replaced this board.
But forgot about that board.
They replaced this board, and this board's got a blown fuse.
Yep.
So, and then this one is the same as what he was just talking about with those blue and brown wires going to your N1, N2, and 3. The same thing happens here. If they cross those wires up, you're not going to get proper communication either. So it's very important that they're following the wiring diagram and the blue wires landing where it's supposed to and the black wire and brown wire land where they're supposed to do, because again, you're coming back to 1, 2, and 3 on that terminals, and it's very critical as far as the way the board powers up the communication circuit. So if we cross those wires up, chances are it won't hurt anything, and it's just a matter of reversing the wires afterwards, but it's hugely important that they get them in the right place for it to function.
The other thing that I'd like to mention is that, you know, if you see that the model has a main board and a filter board, it doesn't mean get both and throw it at it. It means we need the technician on the job to actually see which one they need.
They may need both, but many times they don't need both.
A few years ago, we ran out of these over the summer because everybody was just replacing them. If it's failed, yeah, great, order it. But if it's not failed, then, you know, let's save it for the guy that actually needs it.
So we just got done doing EEV testing and opening out the EEVs. So let's use this board here to kind of point out that EEV circuit and what we can look for as far as burn spots on the board.
So on the control board, you'll see FB and FA. Right next to where those connect on the other side of the board, they connect there. Those are the Molex connectors. Here is these little chips. And what will happen if you have a grounded EEV, you're going to have a burnt spot in one of these little chips. And so there was one particular model that we had, this happened more so than any one I've ever seen. And it was a multi-24 CO. And for whatever reason, some of those EVs would ground and you'd get a burnt chip. So what I started doing was just asking for a picture of the board, of the back of the board. I would zoom in on it when we're troubleshooting E6, and you know, if I saw that burn mark, then I knew before I mentioned getting a board, I knew to tell him, check your EVs, see if one's grounded. You're going to have to replace that as well.
Because if they don't, they're going to just smoke the new board.
And now you've got to get a board and EV. So third job site visit.
That's one advantage that we do with our phone system that we have. We will do text messaging with the guys. We can also do email with them, and we will have them send us pictures. And I tell them, hey, don't get right on top of that board. Stand back and take that picture, because then once I get it on my computer and download I can zoom into it and see where I'm at. And that's what I'm looking for, is any burnt spots on the board, like around the EV or something like that. And then back to the discharge points that we were talking about a minute ago, I will use this rather than dive right into, you know, seeing if I got a grounded compressor or shorted windings or something. If this DC bus is real low in voltage, then I can have them unhook loads. So I can have them unplug the compressor. I can have them unplug the condenser fan motor and then power the machine back up. And if this DC bus all of a sudden comes back up, and let's say I just unplugged the fan motor, now I know the condenser fan motor is what's dragging my DC bus down. Now the mini-split service tools that we're going to demonstrate to you out in our warehouse lab, those actually will give you the DC bus as well. And I've actually taken calls where the guy has had that service tool and his DC bus is low. He didn't have to get a meter on the board, but the DC bus was low. Unhook the condenser fan motor, DC bus come back up, and I'm like, well, there's your problem.
There, you know what it is.
So, and if you, even if you know, you can take it one step further and ohm out that motor as well, and you're probably going to find you got a shorted winding, but that's what's causing it. And it could actually be the compressor circuit as well. But keep in mind, that's only going to happen with DC loads. So if you have like your crankcase heater, your reversing valve, your base pan heater, those, don't even worry about unplugging those, because those are all AC loads. They're not going to drag down that DC bus. EVs though could.
Yeah.
So, you know, if you've got a problem with the EV,
DC,
that could be dragging down your DC bus as well. Yeah. So, just kind of, and then that's the older board. This is the newer board. This board also has those DC discharge points where you can use them for facilitating troubleshooting as well. So now, not all the boards can you get to that, unfortunately, but when you can, let's use that to our advantage. We would demonstrate replacing this board, but when we checked the inventory, we didn't have very many.
We had a low amount,
so we didn't get this board. So we ended up ordering this board because we had plenty of those in stock, and that's what we brought down here for demonstration purposes. But the procedure doesn't change. But what I was mentioning in there on that single zone, if I can get this outer cover to pop off, they're not going to get in there and get to these screws without one, dropping them and losing them, which we can't have, and we'll explain why. And then they're going to have a lot harder time getting all the screws back in and get them in properly. So what I'm saying is the chance of them getting that board changed and that unit functionable without pulling the whole electric box assembly and changing the board, their odds are really low, really low. But once we pull this board out,
there are no lost screws.
Now I've got full access to do what I need to do to change that board.
Right.
So, but again, we're going to demonstrate it on that board.
Daniel, something I noticed in the video, we talked about the Molex plug in between the compressor and the board.
Right.
We talked about it at times, like any other Molex plug, you can have a connection problem right there. What we didn't talk about that I think is important to talk about is the fact that you know, before you condemn a compressor, when you're testing a compressor, and this is the way I do it with guys on the phone, I will have them unplug that Molex plug and ohm out the compressor from the Molex plug, between the Molex plug and the compressor, not the Molex plug in the board. Important to which end we're talking about. But let's say we ohm out the compressor. Now, these are three-phase compressors, so we should have equal resistance across the windings, no matter which wires we go to. We should have no resistance to ground from each wire. And I say that no resistance, I also want to make sure that everybody understands that if you read it in mega ohms, that's a normal reading. What we're looking for is like 0 ohms to ground, 100 ohms to ground, 1,000 ohms to ground. That would indicate that I have a grounded compressor. But if I read like mega ohms, because of the oil in the compressor and the compressor's design, you could actually get a resistance reading from the internal winding to ground through the oil and refrigerant in that compressor, and it read up in mega ohms, and that's normal. Now, we don't want you using a mega tester on it, but most of your ohm meters can also read in mega ohms, and guys think that might be a grounded compressor, and it's not. That's a normal reading. So, but let's say we ohm out that compressor from that Molex plug and we get an improper reading. In other words, say we get open winding. Before you condemn that compressor, you need to go to the compressor.
Way to the compressor.
Take the cover off, ohm out the terminals right there. Because if you get a proper reading there, then you obviously know you got a break in that wire between the compressor and that Molex plug.
And something that I have actually seen before when we're working through a call and we're testing the compressor, you know, the compressor tests out fine. There is, if you saw in the video, there's a little magnet, a little donut in that wire harness that it goes through and it wraps around. So I've actually seen where the wire, one of the wires go into the compressor was rubbed on that donut and it was shorting out to where, you know, if you were testing a compressor, it's fine. But if you test the wire harness itself, you have an issue there.
So I just want to make sure we covered that. And then I've never seen it, but another simple test to do is from, like you said, on a lot of the boards, from the Molex plug to the board, they're soldered in on the board. Not all, some of them have spade connections, but it's important to do an ohm reading from the Molex plug to the board to make sure you don't have a problem with the wiring harness between the board and the compressor. Now, if it's soldered to the board, when you get a replacement board, you're going to get that Molex plug with it because it's soldered to the board. So,
but if it's not soldered to the board and you're unplugging it from the control board, when you go to put it back, just look at your wiring schematic to make sure your U, V, and W are placed in the proper place, because you could be running that three-phase motor backwards.
If you do that, you're going to get a rotation error.
Right.
When you change this board, there's rules you got to follow to make sure you're doing this properly. So first of all, I tell them, before you do anything, take a picture of the board and how the screws are installed on the board, because there's no such thing as a missing screw. Because, and you'll see once I get this out of here, it's all about how this board, remember I told you guys before, these things generate a ton of heat. The heat is dissipated through the heat sink. So not only is it a matter of the thermal paste, but the thermal paste, along with the way this board is screwed down and essentially torqued to that heat sink, all of that plays a role in whether or not the board's going to function when we get done with it. So, I'm going to take all the screws out. Again, I'm not using the screw gun. So I'm pulling all these screws out, and as you've seen when I was pulling these out of here, all of these screws, let me get my fat hand out of the way, all of these screws are recessed. Now these aren't because I already loosened them up. You got to, when they go back in, they have to be recessed like that. That's part of what I was telling when I talk to the technicians on the phone, it's like, look, you have to make sure all of those screws go back in, and the ones that are recessed again, because that's what's going to guarantee you've got that board pinched down to that heat sink properly. So while I'm getting this out,
That one in the center right there.
no, I didn't get them all out.
So if you've ever got a control board without the heat paste, in the past they didn't ship them, and I think Greg, you mentioned that if they do ship it air freight, they ship a part air freight, they can't just put the paste in there.
That's absolutely correct.
So-
if the board comes air freight, they can't legally ship it with thermal paste.
So there may or may not be heat paste in there depending, but for the most part, the stock that we have now includes a little Ziploc bag of heat paste. Also, what I noticed was it's in a bubble wrap, pink bubble wrap. So the board is surrounded with that pink bubble wrap as well. So there's a good chance that they didn't see it, kind of like they missed the remote and throw it away. So if you don't see it, it could be in the bubble wrap.
Blue is in, and brown is ACL. So those are the two wires that Daniel was talking about. You got to make sure you get back in the same place. And then also you have your ground wire. So what I'm going to do, just to be on the safe side, is I'm going to do, like we mentioned before, and just take a quick picture of it. That way we know when we put it back. And what I was doing was also checking my picture to make sure it was clear and I could see it. But down here too, and it's really hard to see, but right at the top of that Molex plug is that little bitty tab. There's the release. And once you grab that release, the wires will pull right off. There we go. There's one, two. And if you get really good at it, which I'm not, you can learn where those tabs are, and you don't even got to pull the insulation back. You can squeeze right through the insulation. And then that's white plug. I actually have the picture, that's in the picture as well. And these are your EVs and this plug here. So you can actually do this after the board is completely out. Now we can just unplug these and move them right over while we got the board out. And we still got the keeper in that one. How do we pull that off?
It'll come out
Oh,
of there.
because it comes out without having to. Look at that. Every once in a while you get lucky. All right. So the thermal paste. So here's the reason why you want to clean off all this old thermal paste. Because if this board was actually failed, which it's not, you could have, the board can burn to a point where you'll get solder pots and they'll lay in that paste. Then, if we don't clean that old paste off, and even if we apply new paste, and we put that down on that heat sink, what will happen is you're going to have that piece of solder in there. The minute you power it up, you just created a direct short, you're going to wipe that board out immediately. So very important that we clean off the old thermal paste. And I also will tell guys on the phone, so multiple things I would tell them. Have a magnetic tray, because there's no such thing as a lost screw. Also, make sure you've got a glove, because you don't want that white nasty stuff all over you. So if you got some glove, you can clean all that old paste off, reapply the new paste, then get rid of your gloves, and hopefully
You
you're
want to
not.
make sure that you're also not smearing the paste into the threads, because that's going to cause a problem as you tighten the screws back down. So you want to kind of go away from it if you can. We've even had things as simple as just some debris, some dirt, some trash in between, and all it was a matter of taking the board off, cleaning it up, redoing the heat paste, putting it back on, and the H5 went away. So, that's where that question comes in, have you replaced the board? And then I kind of have an idea for what pictures I'm going to be asking for and kind of what I'm going to be doing. So
he took it off with a paper towel first. Now he's just using a cleaning wipe to it just to make sure we got all that old paste off of there. Now that brown little piece of construction paper looking thing, that doesn't get replaced. Now some of the board replacements I've seen will actually come with a new piece of that paper, which if you got it, you can change it. The other thing I will tell guys is to do is like, so how do you determine which components get the paste? And the easiest way to do that is put your boards side by side, just like we have here, and you're going to reapply thermal paste to the same exact components. So you do it on the board, not on the heat sink. And then again, like Daniel said, he kind of drags around the holes because you really don't want it in the mounting holes. And you don't need a ton of that paste on there, you just need enough that it gets good contact to the heat sink. And as you can see, the one with that construction looking paper here and here, those two components don't get any thermal paste.
now we want to plug these up first.
Yep.
Prior to putting the board on there.
So I'm going to use this plug first, just so I get it on there right. Then I'm actually going to pull up my picture. I believe it was blue that was on end. I'm just going to practice what I preach.
Green goes over next to that one.
So blue was on end, and I'm going to pull the insulator down over it. Green is in the center.
Yep.
The green,
And
yellow.
then brown next to it.
And then brown is over here. And it's kind of hard to tell, but if I'm going to tilt this up just a minute so you guys can see this, you'll see that fuse is right there. That's the fuse for the filter board, and it is built into this particular inverter. You can see that fuse is part of the board. So that shows that the filter board is part of the inverter driver. It's not a separate board on the new EO units. All right, so now I'm going to see if I can't get this all flipped back around the way it goes. All right, cool. So I'm going to pull this back over here. So the other thing that I've gotten tons of pictures from guys in the field, and this is part of what stems what I was saying about trying to change these boards vertically, is I've gotten pictures of these screws broke off, missing, and it's like, wait a minute. Why? So, because they're trying to do it vertically up in there, they can't really physically get to it. There is no reason why we should ever break one of these screws, because if you're just gently doing this, them screws should be able to tap right in there very gently. And we shouldn't be tightening any of them all the way down until they're all started. And then we want to kind of do it uniformly so we get that board pinched to that heat sink properly. So the only way I can think of that they'd possibly be breaking these off is, one, they ain't getting to the board properly. Two, they're using a impact screwdriver on here, which they shouldn't be using. Or they're just over torquing it. So, as you can see, there was little to no effort to me to get all these screws started. And you'll also notice that I'm not putting any of the outer board screws in yet, because I don't care about those outer screws. What I care about is these screws right here, which is what's going to pinch this board to that heat sink. And they're pretty long-winded screws, as you can tell. So I'm just kind of taking it easy on them. I'm not putting in any effort at all as far as pushing down on the screws. That one just started to grab, and then I stopped where I felt it tightening up. Same with that one. Same with that one. Then what I'm going to do, now that they all start to grab, I'm going to go back to the center of the board, get that one a little bit tightened. Then I'm going to go to this one. Then I'm going to go to this one. Then I'm going to go to this one. As you can see, I'm kind of working my way from the inside of the board toward the outside of the board. Now I'm going to do it again.
Kind of like torquing lug nuts.
Yep, I'm going to give it a little bit
Header
more.
bolts.
Then I'm going to go to the next screw next to that a little more. I'm going to go to the next screw here, working from the inner to the outer. And so there's really no torque specification, but you can pretty much tell the way I was turning there.
Snug.
I wasn't Superman in it.
No, they don't need to be that tight. They just need to be snug.
Then once all those screws are tight, then I'll come back and put these 4 outer screws in. Because ultimately what I care about is those screws. So like I said, the only way they can be possibly breaking those screws off is because they were trying to do that board in that unit.
Yep.
And they were using a screw gun. They weren't getting them started true.
And this board here, you know, pretty easily done if it stays in the unit, but you saw how easily we removed that control box assembly. There's no reason, if it's that easy to remove the control box, you're going to have to unplug all the wires from the board to replace it anyway. So, you know, just do yourself a favor and take the whole box out.
Well, and here's the other issue. As you've seen, when we took that ground wire out over there, I dropped it. Or Daniel dropped it. I don't remember which one it was. You drop one of these down at the bottom of that unit, you better find it.
And, you know, it's okay if you can't find it. Hardware store sells them. They're M3 by 13 or something like that. I believe we have it on one of the slides.
But all they got to do is take the screw with them.
Yeah.
Take one of the other screws
Take
with
one
them,
of the
go to the
other
hardware
screws.
store,
Go to the hardware store and
match up
and
the
get
thread
it.
count, the length, and you should be able to get a screw. But as you can see from when I just changed that board, it's not a hard process, but it is a diligent process that we have to make sure we're following and we're doing that thermal paste properly. Because if you're not, you're asking for trouble.
It's an
So Daniel,
M3
just-
0.5, 15 millimeters long.
There you go. So whether you're doing this board or you're doing this board, that procedure don't change at all. You can see I still got them same screws that are tightening this board, and then what I'm going to do is roll it over and show you that that board is tightening it down into that heat sink. The heat sink, if you look closely where you took the board out of the unit, that is in the airflow. You've got airflow from the fan running across that. That's part of what's keeping the fins cool, to be able to grab the heat out of the board and dissipate the heat off the board so that we don't...
It's all about conduction.
Yep.
So I want to move this board. This is out of a 115 volt unit, and we didn't have one down here, so I just wanted to bring and show this and talk about where we're testing the test points on this. So on the 115 volt units, we don't have a spot to check the DC bus, but we have where the wires connect, right, Greg?
Yep. So if you look, and the way these capacitors are wired, this blue and this brown is going to be giving you the capacitance off of both capacitors. They're giving you the boost off of both capacitors. So I can go up here on the board, because this is hard to see down in that unit. You ain't going to see this very well.
Right.
But I can actually measure that DC bus right here off of the brown and orange wires, and it ought to be 280, 300 plus.
around
Remember, you got a
280,
115 volt unit. It may not be quite as higher as a DC bus. So the thing is, you got to remember is the capacitors, as we talked about in the design and operation, the capacitors that are boosting that voltage and giving us that high DC bus are actually part of the capacitor box assembly. The capacitor box assembly is actually a separate part. You think, well, I could just test those with a capacitor tester. Well, no, you can't, because I haven't found a capacitor tester that goes high enough. These things are, I think they're
2,500, 2,200, something like that.
microfarads or something like that. My meter don't go that high. I actually asked several other friends of mine and stuff if their meters would actually go that high, and they don't. None of them will go that high.
So ACN5 and ACL4 is what you're looking for. So it actually goes right here. That's where the blue wire goes. Brown, ACL4, which is brown. It's as ACN5, which is blue.
Thank you. But let me get this shot on the side of this capacitor. This is how I knew. The blue wire and the brown wire, the capacitors are tied together here. So this is giving you the boost off of both capacitors. Okay. And I just was saying it wrong when the wires come up. So it's brown and blue, just like the PowerPoint shows, which is going to be ACN5 and ACL4. Now, you can see that on the wiring diagram as well. You will see them exact same wires. So the orange wire is essentially in the middle. You're not doing it there. You're doing it on the outer two wires, which is blue and brown. You can clearly see that in the wiring diagram. So if you have the guy on the phone, you pull up the schematic, you can look at the wiring diagram and say, okay, test the voltage here and here.
So another thing about these capacitors, if one of these is failed, you could get E6. So this is a good portion of the E6 issue. A good way to know if one of your capacitors is failed. You see that white plug right there? And then the other one has a white plug right there. Those will either be blown out or a hole in it if that capacitor is bad. That makes sense to me, and I'm glad you showed that, because I've never looked at one like that to know that. So, you know, if you don't have to worry about testing them. If one's bad, you'll see it. So, but that is, like I said, that actually is a separate part. So if you ordered a new inverter driver and the capacitor's bad, it didn't stop you anything. Correct. Because the board may be perfectly fine. You just have a bad capacitor. We have bad capacitors. Yep. So. All right. All right.
All right. Hey, we're back here. Hope you guys enjoyed that video. We do have the FLEXX FXU board replacement coming up next. And don't forget to use that question bar and ask your questions. And again, do we have any questions real quick, Greg?
At the moment, no. So don't forget about that ask a question button over on the right-hand side of your screen. Click that and send us your questions, because as I've said many, many times, we do these trainings for you guys. So if you have questions, we want you to get involved. We want you to ask questions. Just keep it, related to the topic we're discussing today.
That's right. Let's see here. Any key points we wanted to point out, Greg?
Well, one thing I want to point out and talk about is that thermal paste. We talked about it, I believe, in that video, that if for some reason we get boards that are shipped in, they will not come with that thermal paste because they can't include it with it. If the board comes in through normal channels, it will come with the thermal paste. I'm going to share the part number. If you need to order it from us, you can order it. Somebody just call it out first. And then hopefully our camera guy can get it to share that part number on our screen there. I put it up in our chat forum of our video here. You guys can't see that, but our camera guy can. So that part number is AOT 53054. K is in king, D is in dong. I don't know why I said dong. It just sounded funny.
Well, Greg, with that being said, on the the part number for the heat sink, I mean, would you
Not
say
the heat
that
sink? It's the thermal paste.
Thermal paste.
The heat sink, and I'm not trying to mean disrespect, Jesus, but You know, the heat sink is that transformer looking aluminum metal underneath that board.
Right. The
That's your
aluminum.
actual heat sink. And we talked about in that video about putting the screws in through the board and make sure you start them all, you know, first. You know, be very careful. You don't want to strip them out because you're going to strip it going into that heat sink. And the importance of the pressure of that board up against that heat sink and being proper is huge. Because if we don't get the board tight enough, the thermal paste can't do any job. The whole job of that heat sink is to absorb the heat out of the board through that thermal paste. So
Yeah.
and that's why we talked about many times, and Daniel and I in that video, that you know, you've got to clean that old paste off, you got to reapply the new paste, and you got to make sure that you're tightening all those screws back in. There's no such thing as missing screws or I lost a screw, or because every one of them screws in that board is extremely important. But you were getting ready to talk about the thermal paste and whether or not they have it, right, Jesus?
Yeah. So what I was gonna say is, so say for instance a tech, if they had just a generic tube of thermal paste, I would assume that that would be okay to use, in case they don't have the part number that you just listed, in case they don't have that,
Yes.
in their presence. Okay.
Just make sure it is thermal conductive paste, not heat sink paste. Because there is heat sink paste out there, and and chemicals used for, like, if you're brazing and stuff, that'll help hold the heat, keep components from being overheated and stuff that don't transfer heat well. That's not what we want. We want thermal paste that's actually going to conduct that heat from the board to that heat sink.
You want to
So-
bring up a real world example that actually happened to myself. And this had to have been, I don't know, maybe 2.5, 3 years ago, or give or take. But I actually have the board here, in my office. And, if we can probably throw it up later whenever we come back after the FLEXX unit board replacement video. But like I said, I can attest to those screws being very crucial to be reinstalled when you're replacing that board. So what happened was, I was getting some errors and I ended up replacing the board, and I couldn't get, I can't remember if it was either 1 or 2 screws back in there. The point was I didn't get everything back installed properly, and the board actually arced out. And as I stated, I do have the board here on me, and so maybe we can show that after we come back from the FLEXX video of what I'm talking about, because you'll see the IPM that was just pretty much charged right now, and it came apart. And all I could come up with was that it wasn't making proper contact with the back of the heatsink aluminum device that each mini split. It was multi-zone mini split, so it was vertically mounted. And yeah, like I said, I know for a fact that I couldn't get all the screws back in, and that was a result of not getting those screws back in. And it sucks because it's like you replace the board and it's like you get an arc automatically on startup, and it's like, man, what's going on here? So, just a personal testament for myself being out in the field.
That's absolutely what happened, because if it can't dissipate its heat, it's going to overheat that component immediately and then fry it to the board. You're done, because it can't handle the amp draw and the current flow through it and the heat generated from it. So that board absolutely has to be able to transfer that heat to that heat sink. And when the heat sink's mounted up in the airstream, if you look at it. So absolutely critical, and I believe I said it in that video too. I've repeated it over and over and over again. I'm pretty sure I said it in the video, is a magnetic tray is your best friend, because you take that screw out, put it right in that magnetic tray, so we don't end up dropping it down in the unit and trying to find the screws and stuff like that.
Right.
Those screw sizes are 3 millimeter and 5/8 long with a 1/4 inch washer. I know that's a lot to remember. If you guys ever find yourself in a situation you need those screws, you can reach out to our tech team at 888-850-7928. They actually have that recorded in a document that they can send out, just email to you what those dimensions are. Again, it's a 3 millimeter screw. It's 5/8 inch long, and it's a 1/4 inch washer. You can buy them at your local hardware store. You just gotta make sure you got the right size.
Right.
And
And
the
some
thermal paste, like Home Depot, Lowe's, whatever, that's fine as long as it's thermal conductive electronic paste.
right. And something else, Greg, that I do get a lot too is the contractor says that too, I didn't get any thermal paste with that board. Well, a couple times I've had them actually look on the ground around you. It's a little bitty tube, and they're like, why only a little bit? Because we give you the right amount. We don't give
Well,
you
it's
too
not,
much.
yeah, and it's not always even in a tube. If you've seen in the video, it came in just a little, it sandwiched in between two pieces of plastic.
Yeah,
It
it's
wasn't
like a
even
bubble
a
wrap.
tube.
Okay, yeah.
So, yeah, be careful you're not just accidentally throwing away the thermal paste they're shipping with the board.
So guys,
Yeah. So,
I have a question for the both of you. Maybe you guys could talk to this. So would you suggest let's say for instance I don't know, the unit's been installed for a few years, and they're going out to a maintenance, and what they're thinking is, we need to replace the thermal paste, go ahead and clean it off and replace it with, fresh new thermal paste. Would y'all suggest that on any maintenance after
No,
extended amount of
mm-mm,
time? No?
no,
Okay.
no.
no. That thermal paste stays gelled.
Yeah.
It doesn't harden. So there's really no reason for them to pull that board out unless that board needs to be replaced.
Okay.
And I actually tell guys, do not pull that board unless you intend on replacing it. Because when you
Yeah.
pull that up, you're liable to smear that thermal paste around, and then you go put that board back in there. The thermal paste may not be in the right place, and you'll end up now you do need a board just because you pulled it out and put it back in.
Yep.
The important, I believe I said it in the video, if the board before that failed, you have to clean that old thermal paste off, because sometimes you can get solder pots and stuff like that fell off the other boards laying in that old thermal paste, and you sandwich a new board against that, you got direct short.
Yep.
So it's all about just taking your time, and that's why I say, guys, look, I know you got time on the job. You need to get in, you need to get out. You got a million different calls to do that day. I understand all that. Again, I said I'm from the field, but I've also learned in my years of experience that sometimes slowing down and going through the step-by-step process and only having to do it once becomes much faster than trying to
Oh
hurry
yeah.
up through it. Because if you hurry up through it, you're going to make a mistake. Now you got more problems to deal with. You're better off to just slow down, take a minute, and then take the step-by-step process. And then in that step-by-step process, one of the biggest things I can tell you is most of these units now, those boards are vertically mounted up in that unit. So trying to change that board up inside that unit, you don't have small enough hands, and you're not going to hold on to them screws. You're going to drop them,
Mm-hmm.
pull the whole electric box assembly out. And one of the things that I would think, if I was actually running service still today, I'd probably have me a fold-up table riding around the back of the van with me, so that I could go over and open that table up, and I got myself a little workbench to work on. Throw that electric box assembly on there. You're not trying to lean over in your van, stuff like that. You got a nice little table right there, and you can do
Yeah,
what
of
you got
course.
to
I
do.
agree 100% on that. Even using your tailgate, just make sure that nothing falls, obviously.
Yeah, it ain't got to be a big table. A little 2 foot by 3 foot table or something that folds up and you can throw in the back of your van.
Not a bad
So,
idea.
tools are getting better and better every day in the trade. Sometimes I'm jealous. I'm like, man, if I had all those tools when I was in the field, dang, that's cool.
Oh yeah.
So I think it's important to bring up, not that this is I mean, yes, it is a critical piece of information, but I think it would be important to point out that, if you are working on an older 410A system, they are not compatible with the R32 stuff. So don't try and pull the parts off of a 32 piece of equipment and install it in a 410A. You're gonna, well, for one, it probably was not even gonna fit, and for two, it's probably just not gonna function properly. So don't try it, don't do it, don't get any ideas. I just wanted to throw that out there. And you know why I bring that up, right, Greg and JD? Because
Oh
the
yeah.
question has been asked.
That's right.
So there was one question here. Juan brought it up. It says, "Good morning, guys. Are you going to have PPTs?" I'm assuming he's talking PowerPoints, unless there's some other meaning to PPT that I'm not sure
I'd
of.
say PowerPoints, yeah.
But we don't, this is not PowerPoint driven. This is actual video. So we will, after this show is completed, give us about a day turnaround. This show will be rebroadcasted on our channel. So you can go to greecomfort.com. You can get to our videos there. You can also just go to YouTube and type in GREE Comfort and look and then sub search Tech 90s and you'll see them that way as well.
Yep.
So you'll be able to, you can watch this video at a later date and be able to get that information. So, yeah. Now, that was the only question that came in so far. So why, like I said, you know, if you're meant to say something else or whatever, please, you know, just type your question back in again. We'll do our best to share whatever information we got. So, JD, anything else to add? I think, you know, that video, you know, we did that a while ago, but you know, it was on 410 equipment, I believe, but the processes don't change much. I think we actually did it on new R32 multi-zone unit as well. I don't remember, but that process is the same. It doesn't matter, you know,
Right.
as far as board replacement goes. You know, but I think, JD, you can attest to, you guys get a lot of phone calls in the tech department where boards have been replaced once, if not twice. Sometimes the third time they're finally calling us.
Right.
You know, if you put one board in there and it don't go right for you, get on the phone with us, because
Exactly. Yep.
let us help you determine what you might have done wrong so that it don't happen again. You know what I mean?
Yeah.
So
We're here to
not
help.
here
We're not gonna bust your chops, you know. Like, we're not
We'll
gonna
do
make
that
fun of
after
you.
hours, right, guys?
Yeah, we'll do that amongst ourselves, but at the end of the day, like, we want you to call us. That's what we're here for.
JD, I'm glad you said that, because I was getting ready to say the same exact thing that you just said. I mean, the last thing we want to do is give people a hard time about making mistakes. You know, we've all made them. I was in the field. I made plenty of mistakes when I was field. Let me tell you, I'm just glad I lived through them to talk about them today. I mean, you know, I had some mistakes that, you know, if things would have went one step further the wrong way, I may not be sitting here right today. So the
Right.
job we do out there is dangerous. You know, you got moving fan blades, you got high voltages to deal with. These inverter drivers hold voltages. That's why I'm saying this to you. Don't go shoving your hands into that board right away, right after you just powered that thing down. Give it some time to dissipate the charge, you know, and if you don't have those DC test points that we talk about in the video, and some boards, they're all there. It's hard. Some boards it's easy to get to them. Some boards it's not. Sometimes
Yep.
some boards it's easy to identify. Sometimes it's not.
Right.
If you're not sure, just power that thing off for 10 minutes and, you know, go talk to your girlfriend on the phone or something. And then come back, you know, and then
Yeah.
now, okay, it's been off for 10 minutes. You should be good to get your hands in there.
Yeah, we
Another
show that.
thing
We show that real good on the next upcoming video too. We kind of watch that DC voltage even dissipate and go down. So.
Right, and that's great on boards that you can get to that. You know, you can't get to it on every single board. So when in doubt, just leave it off for about 10 minutes and then come back to it. Well, the other thing I want to tell you is if you do get in there too quickly and you're lucky enough to not get shocked and you disconnect high voltage loads like a fan motor, compressor, stuff like that, now you've just taken the loads away for the board to be able to dissipate that voltage into. So if it has no compressor windings and no fan motor windings, it has no place to dissipate the voltage to.
Good
So
point.
you don't want to do that either. So you
Mhm.
got to give it time to dissipate the voltage so those capacitors can actually discharge. So another reason why you wait or know that voltage is dropped on the DC bus before you get your hands in there. So.
Yep.
All right. Anything, JD? You're kind of running the show here. Is there anything else we need to talk about before we jump into the next segment?
No, I think we covered it pretty well. We can go ahead and run the next segment, and again, just remember to ask those questions on the right of your screen there.
Hi, JD with GREE. Today I have Craig Lynch with me. He's our new addition. Say hi, Craig.
How you doing?
All right. And then, so today we're going to actually show you how to replace the board on this unit. It does have a cooling loop rather than the heat sink, so we're going to show you how to remove that. and replace the new board. And a little bonus, we're going to show you how easy it is to take this front cover off that exposes the board. Take the top cover off, front cover slides right off and exposes the board, and then we can get right into things.
Today, the tools we have for the job are a small thermostat screwdriver, a flathead screwdriver that's longer to get reaching a little further, a pair of needle nose pliers, a pair of dikes, a regular pair of pliers, some zip ties when we're finished to put things back together, a magnetic tray to catch your screws, a voltmeter to check your voltage and your bleed down resistors to make sure you're at 0 volts, and then of course a screw gun to make time go a little faster.
So now that we've gone through the tools, let's go ahead and get started. We're going to remove these tools off of here and pull this cover off. So there's just a couple screws up here on the top, around the top and side. We're going to remove those. So they did redesign this front cover, how it comes off. I like it. All you have to do is take the top cover off, then the front, there's a couple screws on the front cover. The front cover comes right off, exposes the whole board. All right, so we just take this top cover right off, just lifts off of there. Then right behind here we have 3 screws. Right here holding this fan bracket, and then attached to there. Go ahead and remove those. All right, so now that we've taken these screws out on the front, this front cover comes off really easy. Again, if we have power on, because we're going to show you how to watch that power down, so be careful when you're taking this off. This front cover lifts up, slides out. This other cover lifts up. Boom, your front cover is off. Now the board is exposed. As you can see here, we have power to the board. Let's go ahead and turn power off. Now this does hold charge for, 10 minutes. As you can see, power is off, it's still flashing. There's a little red light down here. You may still be able to see that. That is a good indication that there's still power in there. What we're going to do is we're going to show you where to test on this board here. So if you want to hold that meter, right down here, there's a little plug. It says DC out. Just be sure not to touch anything in there. So as you can see, we still have 39 volts DC. You can slowly watch that go down. Again, when that thing's powered up, we're going to have somewhere right around 300 volts DC. So again, that can light you up. So as you can see, it's slowly going down. We're at 35 volts DC now. Slowly going down. So that red light right here is still on. It's a good indication that that board still is holding some voltage. Again, I would wait about 10 minutes or until this is down to 0. You can do whatever you like. You can wait 10 minutes to know you're safe, or you can sit here and kind of watch this go down. Again, we're down to 27 volts DC, slowly going down. So we'll give it another minute or 2 here. We'll check it here soon. Again, can't stress enough, this plastic housing, as we'll show you here shortly, does not come off. Just the board removes from that plastic housing. The plastic housing stays on. Let's check that voltage again. All right. So as you can see, we're down to 0 volts DC. Let's switch and make sure both sides. 0 volts DC.
Now it's safe to work on the control board.
Now it's safe. We can go ahead and get our hands in there without getting shocked. So with that said, let's go ahead and we'll start getting these wires unplugged and show you how easy it is to take this board out. These 2 wires right here, the power wires coming into your main board from the filter board that's behind here. Still easy to access that filter board. This is your cooling loop in place of your heat sink. Going to dissipate that heat off the board. There is thermal paste inside here. So what we're going to do is actually show you how to remove this. Of course, this pulls back, slide the board out. You can slide your new board in. We're going to show you how to do that. One thing to keep in mind, this plastic housing right here, goes all the way around, that the board screws to, stays. The new board does not come with this plastic housing. When you remove the board, you just remove the actual circuit board itself. So we're going to go ahead and get started with that. First thing you want to do is cut these zip ties here. All right, so now we're going to use our little thermostat screwdriver to remove these tabs that are on here. As you can see, there's different color ones for different color plugs. That's just an extra precaution to help those from during transit, whatnot. You just kind of pop those off. They slide out. Let's put a little tray right here. So we just remove these tabs. Coming along here. Something else you see, if we can zoom in real quick. All right, right here, your dip switches. You have SA1, SA2, and SA3. As long as you set those up properly, which you can look at our quick start guide, make sure they're set up properly. I would mirror what your old board had to the new board. And then there's these jumper caps that you want to pull off. So you pull off these jumper caps, and just wiggle right off, slide on there, slide back on. And there's a blue plug and a gray one. So the base of that actually matches the color of the jumper. So it's something to keep in mind there too. But we're going to go ahead and finish removing these plugs here. All right, so once you remove those little retainer clips, then there's just a tab lock release. You just hit that little tab lock, they come right out. Sometimes it might be easier to use the little pair of needle nose. Just one of those retainer clips. And actually, I don't need that. Just do that. All right. All right, got all the plugs unplugged. Besides the one down here. Then you have your compressor wires. You have your UV and W, blue, yellow, red. The best way to get those off, because those tabs actually do lock onto that hole in that spade, is to slide the rubber back on these. Slide the rubber back, and then you can actually use your little thermostat screwdriver, and there's a little clip on the bottom side. Yeah, maybe. Kind of push up on it a little bit. Releases that tab. And you don't want to put too much force on it. You don't want to mess up that board. Again, they slide right off. We just have two more wires here, your incoming voltage wires. Phillips screwdriver to undo these power wires coming in. And it's never a bad idea to take a picture of all these wires. Obviously the plugs are color coded. As you can see, the bases all match the wires, but it never hurts to take a picture, like for your compressor wires, for these wires, or you can look at the wiring diagram. We'll take off the side cover really quick. So either take a picture or you can look at the wiring diagram just to make sure. It never hurts just to confirm with the wiring diagram that you have everything done correctly. So now that we have everything undone from the board, besides our ground wire, go ahead and undo that. You're going to remove the screws. Again, you do not remove this plastic housing, this covering. That stays on the unit. That does not come with the new board. All right, so you're going to find actually there's 8 screws, 4 on the perimeter, 2 in the center, 3 in the center right here, and then 1 hiding over here between the capacitor and the copper coil. And then we have the screws here. There is a cover that goes over this refrigerant pipe that comes up as your cooling loop. There is a thermal paste below there. So again, when you're doing this, again, we're not putting a new board on that has the new thermal paste. Wouldn't hurt to wear some gloves. That way you don't get that thermal paste all over your hands. All right, there's 2 more screws here. Some of these screws, especially on the board, I would not use your drill. That way you don't crack the board, crack the circuitry, or over tighten this. Never hurts to do it when you're taking off the covers though. That will definitely speed up your process a little bit there. All right, so got the screws out. There's a little clip at the top that holds this in place. So you can see the thermal paste is not on this cover. Basically, we'll go ahead and set this down right here. There's a little thermal paste on the side. But again, when you're doing this, it wouldn't hurt to use some gloves so you don't get this all over you. The top here, there's no thermal paste, so you grab it by the top. You're going to pull that refrigerant line back. So then that frees up the board. There's these tabs that you're going to have to push in on this side over here. That releases the board. This board will slide up and out. Slide up and out. Okay, so now, again, like I said earlier, going to remember you have your jumper caps that you're going to pull off this old board. You're going to put these jumper caps onto your new board. They are colored, so you can see here, blue and gray. That you're going to put back on there. Then you would have a tube of thermal paste that comes with the new board. Going to apply your thermal paste to there. Just a good bead across both sides. Then you're going to slide the new board in. Again, there's a little tab locks in there, so it kind of holds it into place for you. It kind of helps you a little bit. Then we just put those 8 screws back in. Craig, you want to go ahead and do the do the honors? So then we push this refrigerant pipe back in there too. Kind of just move to the side. Goes right back in there. We have our little cover that goes on there. And we'll slowly just start putting these wires and plugs back in. I'll go ahead and get started on that, Craig. Again, these plugs are colored to match the plug they're plugging into. So there might be a couple of the same color ones, but they're all different number plugs, so they won't plug into the wrong one. So that makes it real nice and easy. Again, you don't have to worry about putting those tab locks back in there, because again, each one does clip back on there. They are secure. That's just an added safety measure. So we're going to put that. We can put the cover. So again, there's that little latch at the top. Goes right to the top there. I'll hold it in there for you. Yep, here's that little tab that goes right in on top of there. It holds the plate in place. And we just reattach those 3 screws, or 4 screws.
3 screws in the ground wire.
Yes, 3 screws in the ground.
And don't forget to address your dip switches. It's easier to look at it while the boards are out.
Yes. Good call, Craig. So another reminder, you have your three banks of dip switches down here. Just as long as you have your dip switches set properly on the old board, you just mirror the dip switches to the new board. It says on, there is no off, so just be sure to get those set properly. So again, you have your jumpers, your dip switches. Put this on. Make sure you get all your wires plugged in. So it looks like we have all the wires plugged in. Not missing anything there. Plug in the condenser fan.
And then this is your three-phase compressor wires.
So we have U, V, and W. So let's go ahead and pull out our wiring diagram. What we're doing is hooking back up the compressor. Being so you can plug those in any way, we want to make sure they're plugged in properly because that could cause that compressor to try to start backwards. We don't want that, or damage the compressor. So here we have the wiring diagram that's on the side cover that we showed you earlier. And then we have our blue, yellow, red. That's our UVW. So blue goes to U, yellow goes to V, red goes to W. Again, that's critical. You want to make sure that you get these compressor wires hooked up properly.
And then just give them a tug to make sure they stay on tight.
Give them a good tug to make sure. Wouldn't hurt just go through, make sure all your wires are plugged in everywhere. Make sure they're all clipped in good. So we're good there. Got our jumpers on, dip switch is set. Now we just have our power wires left. So again, let's use the diagram here and make sure we're going to the correct one. We have brown goes to X1.
Yes.
Black goes to X2. We're going to go ahead and just power it on, make sure that the board comes on. We do have the disconnect turned off. All right, so now we're going to go ahead and put the covers back on. We're going to turn power off just to be safe while we're doing that. All right, so now we powered the board back down. We made sure we're back down to 0 volts DC just to put the covers back on. You never know, you could bump something just to be extra safe. In the meantime, we kind of, you can clean up kind of tools, start cleaning up the job. As again, we turned on the board, made sure there's no faults. You can turn on the unit, make sure it runs. Briefly, with having the cover off, just be careful with the fan exposed. Obviously, you can't run and check pressures. But again, we just never hurts to turn it on, make sure that our fault went away that we had before. So with that said, let's go ahead and get this cover back on. So again, you start this left side first. There's three little tabs here. You can see those tabs. There's 3 tabs over here that you just line up, and a little locking groove at the top left here. Boom. Unit's back on. Now we put our screws back in. I'll let Craig do that.
Yes.
All right, so we have our 3 screws at the bottom, 3 screws at the top. Kind of slides on there. We have our screws around the top. As you can see, that front cover goes on real nice and smooth along with that top. So again, they made it, how they changed it, I think they made it more convenient, user friendly. You don't only have, less than a minute to take it off, put it back on?
Yeah, it's no time at all.
So again, makes it real easy to service this unit, which I like. So you see that board replacement didn't take too long to do. So again, they made that, one of the improvements that they did to this unit is just make everything a lot more accessible, easy to get to. That front cover comes off, exposes that board. All right, well, thank you, Craig.
Thank you.
All right, so now we just showed you, how to take the door off, put the door back on, replace that board. Couple key takeaways. Again, when replacing that board, remember, use a thermal paste that comes with it. It's a little tube that comes with the pack. Again, goes on the heat sink or on the board itself. Remove the 2 jumpers off the old board, put onto the new board.
Set your dip switches.
Set your dip switches, mirror them from your old board as long as your old board you had set up properly. If not, go to our quick start guide on greecomfort.com. With that said, thank you for your help, Craig.
Thank you.
And again, with GREE, we're by your side.
All right, welcome back, everybody. I hope you guys liked that video. I don't think we have any questions in us right now, but don't forget to ask those. A couple things we did want to talk about those videos, especially the jumpers. There is jumpers that are actually on the indoor boards on the FLEXX air handlers too. So don't forget about those if you replace those boards. And
Well,
also just
let's just
in our,
talk about jumper caps in general.
okay, fair enough.
And we want to make sure we're calling it a jumper cap and not a jumper.
Good.
Because I
Yes,
made the
good call.
mistake of saying jumper to a tech, and he thought I meant a little actual
Jumper wire. Yeah, like
So
a jumper wire.
I'm like, oh, okay, yeah, that's clearly my fault. We
Right.
need to call it what it is, which is a jumper cap. So pretty much across the board with a lot of GREE's equipment, whether it's an indoor unit or an outdoor unit, many times those jumper caps are on there. Many times, though, they have two jumper caps. I believe the FLEXX, if correct me if I'm wrong, JD, has two jumper caps.
Yep,
So
we
does
showed those
the-
in the video.
Yep, so does the Multi-Pro Ultra unit. It has two jumper caps on it. One's gray, one's blue. Very important to understand that when you get a replacement board, those boards do not come with those jumper caps. Whether it's an indoor unit board, or it's an outdoor unit board, we need to make sure we're looking at those boards, and if they have jumper caps, remove them so they can be put onto the new board. We can order jumper caps. We do stock some jumper caps. We don't have all of them. I'm just being frank with you guys that, you know, if you order a jumper cap that wasn't moved from one board to another, hopefully we got it. If not, it's going to be several months before we can get it. It just takes time. So let's be careful and take our time and make sure we're looking at boards and seeing if they have jumper caps. To help with that, as you've seen in the video, we show the jumper cap. In that video, he showed you both the gray and the blue ones. They always have a numerical number on them, and you can't just move them from one piece of equipment to another because that number is what is jumping a certain set of pins.
Yeah.
So to show a little bit more about that, we want to show you on our website in our parts lookup tool. So if you go to resources, kind of follow along with us here, and then you're going to go to product support and then parts lookup. Now, if you know the model serial number, you should be able to get the part number that way, but also you can type in jumper, and then you'll see all these different jumper caps listed. So you got blue ones, you got gray ones. The key factors, if you look at all those part numbers, they're the same. The part numbers are the same except for the last two digits. So that one there would say 17 on it. There you go. So whatever the part number ends in is the number that's on the jumper cap. So if you know the number, you can go to parts lookup and just type in jumper, and then you can look for the number you're looking for. Or you can just copy and paste. What I've done is I'll copy and paste the part number in there except for the last two digits, and then add the two digits that I need in there. So like say I need to know 01, I can take that part number that's in there, copy and paste it, all except for the 05 up into the search bar, and then change the last two digits to 01, and you're done. That would give you one with a number 1. So I'll show you that. Copy, paste, and then add 01. And there you go. There's your part number. Just make sure the colors match too, because I think there is a difference between the blue and the gray. So
yes,
be careful of that. If you're ordering a blue jumper, you need to make sure you're getting a blue jumper. If you're ordering a gray jumper, make sure you're getting a gray jumper. So, but to avoid all of this, you should be able to just take the jumper cap off of the original board and put it on the new board. Now, talking about capacity dip switches. As far as right now, FLEXX R32 equipment, the FLEXX 410A equipment, does not have capacity dip switches. Not as far as capacity identification. They may have a capacity dip switch that you can change it from like a 2-ton to a 3-ton or a 4-ton to a 5-ton. That's not what I'm talking about. I'm talking about capacity profile for the board. Okay. Indoor units do not have a capacity set of dip switches that sets the capacity of the unit to along with the jumper cap, identify the capacity of that unit, meaning either a 2-ton or a 3-ton or a 4-ton or a 5-ton. Because even though you're setting that dip switch, it makes it 2-ton or 3-ton, there is still also identification for the board to know it can be a 2-ton or a 3-ton, is what I'm getting at. Those types of capacity dip switches are not on mini splits. They're not on the FLEXX equipment as of right now. When you come into commercial equipment, that's a different story. So if you're replacing a board on a multi-pro outdoor unit or a commercial GMV unit, whether it's VRF or heat recovery, those boards absolutely have capacity dip switches. And when you get the new board, you need to make sure the capacity dip switches match the capacity dip switches of the original board. And any jumper caps that may be on the board get moved as well, because they work together to identify the capacity of the unit. So I can't stress that enough, guys. GREE's been doing this for quite a long time now. I know other manufacturers use some sort of a capacity jumper or a chip that identifies the capacity on the unit. I've dealt with this with other brands as well. Again, you know, if you, I tell guys all the time, you know, I don't know. I hope the distributors are not making you turn in the board before you get a new one. They may want the board returned because they do have to hold on to them. But you should be able to have those boards side by side before you turn in that old board, so you can look at things like that, jumping, you know, capacity jumpers that need to be moved over that don't come on the new board, capacity dip switches, that kind of thing. You need to have both them boards side by side before you give up that original board.
Yep.
I can't stress that enough, guys. We get this phone call all the time, and the code is either going to be a C4 or C5 air code, which is a jumper cap air code. And if it's not on there, that machine is not going to run. Period. It will not run without the jumper cap. JD, Jesus, you guys want to add anything to that? I think I covered it pretty well.
Yeah, you covered it really well. Yeah, just the C5 would be an indoor jumper missing. C4 would be the outdoor jumper missing. So, but yeah, you covered that really well, Greg. Thank you.
I think we're doing a much better job of stocking jumper caps. But like I said, I'm not going to sit here and try to tell you guys we have them all. So just be careful when changing boards. You know, when I say all, you got units 4 or 5 years old, chances of us having that jumper cap is pretty slim versus a brand new unit. Again, a brand new unit, we're trying to bring in parts to support that brand new unit. Jumper cap maybe not one of them was high on the priority list. I don't know. We don't handle the parts department. We're the tech guys. So anyway, but we, you know, from the time that I've been here, which has been almost 4 years, we stock a lot more jumper caps than we used to. I can tell you that.
Yeah.
So, all right.
Any questions rolling?
Yeah, I just want to make sure I brought that up because, you know, it's coming up over and over and over again, you know, and I just, you know, I figured what better way to do it to make sure we get it out in broadcast. And this is not the first time I've talked about it in broadcast video. I know I've talked about it many other times. So as of right now, any more questions coming in? No, we got none. So, hey, to keep things alive, keep things active, make sure we get your questions asked. Out of the over 100 people that are watching this right now, I can't believe you don't have a single question for us. But just maybe, we did those videos so good that we answered all your questions during the video. You know, I'll take that. What about you, JD?
Yeah, I mean, even if you know, if you've had this experience yourself, has anyone, you know, that's listening replaced one of these boards and had this issue? We'd like to hear from you. But we do have a couple events we can, you know, go over while we're waiting to see if any other questions come in.
Awesome.
So yeah, if you guys would like to go back and revisit the training today or any past trainings, we will have this posted on the YouTube GREE Comfort, and you'll be able to find it on our website. March 11th, we have a Talking Comfort Live, going over Master Zone, deep dive, unlocking the multi-zone performance. And on March 26th is our next Tech 90. We're going to be talking about the FLEXX R32, going over the installation of that. So we'll take a deep dive into that. And that's all the events we have coming up.
I guess we'll just wait a little bit for any questions to come in, but I just wanted to re-emphasize, the importance of what, the topic that we just got off of was the jumper cap. It's guys, you can attest because I know you can because I've taken the calls where the guys, they're like, this unit doesn't run for no reason, and they're over here deep diving into electronics, deep diving into the compressor, deep diving into whatever the case may be, and they send you a picture and what's missing? The jumper cap. And it's like you could have told me that at the beginning. You could have sent me this picture at the beginning of the call, and we would have resolved your issue then and there. Because there's nothing you can do. There's nothing you can do with that jumper cap missing. It's a stalled system. It's pretty much until you get that jumper cap.
I took that call yesterday, Jesus. Funny you say that. Contractor called in. This was a second board, and he replaced the motor, and still nothing working. I'm like, we're not going to have a bad board and bad motor.
Right.
So then I asked him the question. I said, it's your second board, right? I was like, yeah. Or he said, yeah. I said, did you move that jumper? And he said, what jumper?
Yeah.
So we found the original board, put the jumper on there, everything came on and worked. So
a little bit of context to that, though, JD. The job that you dealt with, we talked about the C4 and the C5 air codes.
Yep.
But with FLEXX, the indoor board doesn't have a display. So all you get is the idiot light. That's what I like to call the little flashing light. I call them idiot lights.
And they didn't have H1
So
and
the
H2
idiot light
hooked up.
doesn't exactly tell you what's wrong with the board. It's just telling you there's a problem.
Yeah.
So
yeah, and they had
I hate flash codes. Always have, always will. I would much rather have a 2-digit display to give me a code.
Right.
But unfortunately on FLEXX it don't have that. So
yeah, and he didn't have the H1 and H2 hooked up, so we didn't get that code on the outdoor unit. If we had that hooked up, I would display that code on the outdoor unit, and we would have known there too. But
so keep that in mind, guys. The only boards that can possibly give you an air code is a board that's capable of giving you a 2-digit display, like a wall mount or a cassette, or like if it's a ducted unit, that board does not have a display. Now on GMV, you have a wired controller. The air code would be displayed on the wired controller. Same with a mini split. If it's a ducted unit, you have a wired controller. The air code would be displayed on the wired controller because the board doesn't have any display. But if you're using FLEXX, FLEXX can be set up as a 24-volt system. So there's no way for that board, 24-volt wise, to communicate to a 24-volt thermostat and give you an air code. So if you just think about it a little bit, you can understand why you don't get an air code on some of the FLEXX indoor units, but you do see it on mini splits and multi-pro and stuff like that. So you got to have, the machine's got to have the ability to be able to talk to a 2-digit display.
Yep, good point.
Otherwise, you're going to get the flashy light.
Yeah. And that's exactly what they had.
Yep. But so at least it's flashing the light, something's wrong.
But you know what the contractor said? The contractor even said, man, I wish I would have called you sooner.
Yeah.
Yeah. And I've had this said to me before. Some guys don't want to call tech support because they don't want to look stupid or ask stupid questions or what they feel is stupid questions or whatever. And guys, I'm going to tell you this all the time. I said, there's no way you can know it all anymore. And you guys, unlike us, are working on multiple different brands of equipment when you're out there in the field. And the way technology is moving, there is no way you can keep up with it all. So I encourage you to call our tech support team anytime needed and ask that stupid question. It may be a stupid question to you, but it may be a simple question to us that's asked all the time. Here again, like JD said earlier, we're not here to beat you up. Our job is one job and one job only, is help you get that equipment back up and running.
Yep.
That's it. So now what we say behind the scenes when we're not on air and stuff like that, we have some fun with it, but what you don't know won't hurt you. It's all good.
That's right.
That's for our private subscribers, right, Greg? GREE After Hours.
Oh, I'm sure some people have some live comments about me that I don't get to hear. So that's okay.
That's right.
I can take it. So I don't know about punches anymore. I don't think I could take them anymore. I'm getting too old for that. We'll let JD or Jesus be the punching bag. I'm gonna duck out the way. So let's see if any more questions popped in here. Okay, here we go. Gary, on another note, is there a control that will allow one wall thermostat control multiple indoor units? On multi-pro equipment, yes. Mini splits, no.
Yep.
Multi-pro, we can do up to 16 indoor units on one controller, provided they're on the same system, meaning they have to have the same outdoor unit. If you're doing multiple indoor units, but you have multiple condensers, then no. Now you would have to go to a central controller. We can still do it, but it'd be one central control, and you can set up for controlling all of your indoor units. Then we also have other backnet accessories and stuff like that. We do have backnet for mini splits, so you can do it that way. You can do that's through a third party. It's a cool automation, and you can do it through you do 1-to-1 or 1-to-12 indoor units with one cool automation control. So if we go to resources on our website here, and then we're going to go to system documentation, which is under documents. Down under documents, go to system documentation. Over on the left-hand side, you'll see cool automation. Click on that, and then mini split controls. And there's the GMV GMS -GW1. That is for one mini split. And the GMV GMS GW12 will do up to 12 indoor units. Now you do have to use there's a specified XK76CA wire controller you have to use with each of the indoor units to be able to do the wiring and stuff to make it all work. But that works well, and that allows like if in like commercial applications and stuff like that, where they want to bring all those units in the back net and hook it up with the rest of their systems that they're controlling. So like, this is ideal for like server rooms. So you got a couple mini splits in a server room, and they want to be able to control it through all their controls for the whole commercial building into backnet. That's the way to do it. So anyway, I believe that answered Gary's questions. Any more questions? Let's take a look. Oh, here we go. So Stephen asked, does tech support answer now, or is it still leave a message? It's still leave a message. We take the calls in order received. Make sure you leave your name, phone number, and at least one model and serial number to get the call started, and then just a brief explanation of what's going on, and one of the tech guys will get back to you just as quick as we possibly can. So,
Yep.
JD, anything you want to add to that?
No, I mean, to me, it beats it's the same difference as sitting on hold, but you don't have to sit there and listen to the hold music. We're just going to call you back as soon as you're next in line. So.
Okay, JD, this question's right up your alley. I'm going to throw you on the spot.
But no.
There's no point in not telling the truth, the whole truth, and nothing but the truth. So help us God, right?
All right.
But here we go. My FLEXX R32 controller overshoot on heating mode. Is there a fix?
So if we switch it to 24 volts, it does go from 5 degree to a 3 degree differential. So that's one way. You can still leave H1 and H2 connected. We can still check, all the data, and just operate it as 24 volts and only have a 3-degree swing. Ideally, that's what I have mine here set up my house, on a 3-degree differential. So, but otherwise, we can use any 24 volt thermostat you like, as long as we, move those dip switches, on the indoor and outdoor unit SA1 number 1 to the on position. Then you can use any thermostat you choose.
So I'm going to elaborate on that a little bit more. You can use a third-party thermostat, use 24 volt. A lot of people think that you sacrifice efficiency or operational characteristics by doing that. FLEXX is designed really around 24 volt and then was made to also be communicating. So your loss is minimal, if at all. As JD said, if you still hook up H1 and H2 between the indoor and outdoor unit and then you use a third-party thermostat, whatever your liking is, I would stay with a quality brand, like a good quality Honeywell thermostat or an Ecobee thermostat or a good quality White Rogers thermostat. Those are just name brands that have been doing thermostats for a lot of years, right? And then you're still allowing the indoor unit and outdoor unit to communicate information back and forth through that H1 and H2. So your efficiencies and the functionality of the unit really doesn't change, even using a third-party thermostat. So there's nothing wrong with that. Or like JD said, take the GREE controller. That GREE controller is capable of doing RS-485 communication. It can be set up to use that way, or it can be set up to use as a 24 volt thermostat, which will give you a little tighter swing on your differential there. So, Jesus, anything to add there?
No, I think you hit the nail right on the head, man. It's when we're talking about 24 volt hookups, obviously we get on and off from a 24 volt thermostat, but we're not necessarily, like you said, losing efficiency because the system's not necessary. Yeah, sure, it's getting a command from the thermostat to turn on and off, but really it's relying on the envelope within itself to adjust parameters as needed. So yep.
So Stephen also asked the question, how do I refresh R32 wire controller BIOS? Okay, so GREE's getting better with that. On a lot of their controllers, if you connect it to Wi-Fi, and then somewhere in the settings there, I'd have to go back and look, but you can actually see what version it is, and then as long as it's connected to Wi-Fi, it will download. You can get it to download the latest version of software that thermostat's running off of. So, but I think that swing with RS-485 is a little more involved than that. I think it also has to do with some programming on the outdoor board. The one thing you got to remember, guys, when it comes to the mini-split world of manufacturing, and I say that term lightly, mini-split, flex, multi-pro, your main driver board and that type of equipment is in the outdoor unit. It's not the indoor unit. The indoor unit only does what the outdoor board tells it to do, other than the indoor unit relaying set point information. In other words, room temperature and set point. Other than that, the brainchild's outside. So without an update to that board, I don't know that you're going to see much change. Now, they're still working on the GREE FLEXX service tool. We just recently had that hooked up down at the lab. They've already made some updates to it. I was able to download it onto the service tool that I have. It's like a prototype. It's not quite there. So I've got some information I want to talk to GREE about with that controller, and then hopefully we can get that a little better. And then once that controller will be able to, down the road, don't quote me how fast or anything else, I believe you're going to be able to have a program on that controller that we could actually flash the board on the outdoor unit to a newer program to, you know, rectify any field issues that might be going on from that program. Okay, so overall, though, I mean, the operation is good. With the units, it's really good actually. But right now, I think you're going to find the best differential part that Steve was talking about is using the 24 volt or using a third party thermostat 24 volt. And then as long as you leave H1, H2 connected between the indoor and outdoor unit, once the service tool becomes available, there's a pigtail on the indoor unit. You can plug the service tool up. There's also a pigtail on the outdoor unit. You can plug the service tool up, and then you can get diagnostic information. And hopefully down the road, we'll be able to flash updated programs as well.
Oh, Greg and JD, I just wanted to mention one more thing before we get off air here. But for everybody watching, distributors, technicians, be on the lookout for the FLEXX R32 Quick Start Guide. It's already out right now, but there was some updates made to it. It should be posted either today or later on this week. But just be on the lookout. There's a couple different notes in there that'll be able to help you out in the field further, you know, understand what's going on with dip switch settings and connection strategies. So be on the lookout.
And we're also working on, JD can attest to this, we're also working on, because dual fuel coming along with FLEXX and stuff, those wiring diagrams that come in the instructions and stuff, the lines crisscross everywhere. They're hard to read. So that's the other thing we're working on. Give us another few weeks. Hopefully we're going to have some really clean, colorful wiring diagrams to help take some of that mystery away from you guys as well. Whether you're doing FLEXX with an air handler or you're doing dual fuel and you know, the first time I looked at the wire diagram, I'm like, my God, you know, you really got to try to follow along with a pencil. That's not fun. So we get these cleaned up. So anything else?
No.
Let me refresh, see if we got any more questions that popped in here. Oh, we do. Sweet. Steve said firmware is what he meant. I believe we pretty much answered that.
Yeah.
Is what he's looking for. Andre asked a question about, are there GREE compatible zoning boards and dampers on the market yet that will be able to control airflow and cooling capacity? When you come in inverter units, guys, you got to be really careful about zoning. You know, in zoning with FLEXX would be 24 volt, right? So you got you have to use it as 24 volt, but you got to be really careful because, you know, if you're doing, like say you got a 5-ton unit and one of your zones is only a quarter of that 5-ton, that's not enough zone. That system's not going to work right. You're not going to move enough air. You got to be really careful. I would not go. You got to stay at least 50% greater than the nominal capacity of the outdoor unit before you start, you know, zoning each zone. I mean, that's my opinion. But zoning and inverter driven equipment, the one thing I got to tell you is you just got to be really careful doing that because these machines we don't want to. Let me put it this way. These machines do a great job of protecting themselves. You start giving these things lack of airflow, or even if you're using a bypass and you're letting the evaporator get too cold, the machine is not going to slow down like you want it to. It will slow down, but it's also going to go into save mode. And it kind of gets hung in there, and you don't want to do that to the equipment because then when you do that, now you're triggering excessive oil returns and stuff like that. JD can attest that low airflow on these machines is an issue. So just, you know, we're not gonna tell you how to zone an inverter unit. All I'm gonna tell you is be careful with zoning and keep, you know, don't over zone it. That's not what it's made for. If you really want to get into zoning, we have a unit for that. It's called GMV. It's called Multi-Pro. We can zone by refrigerant and multiple indoor units. That's the way to zone. So,
Yep.
another question. On another note, is there someone I can send a print to see what equipment would be needed for cannabis grow building? Hey, Seuss, I'll let you take that one.
Now, asking, it sounds like you're asking for a bid, takeoff. If
And it
that's what he's
sounds more
asking,
commercial, so
right? Yeah, if that's what he's asking,
he needs to
it
go
is-
through his local distributor.
yeah,
And if you are the distributor, then I would email our GREE Pro.
well, that's where I was gonna go.
Yeah. Sorry, I didn't mean to answer the question for you. After I gave it to you.
Yeah, that was seriously, send in your takeoffs, and we can, if we have something that'll work, for sure, we'll better quote it out.
Northern Plumbing. That's a distributor, right?
Northern
Northernplumbing.com.
Plumbing, yes, I believe that is just. I feel like that rings a
Yes.
bell.
Yep, he needs to email our GREE Pro,
Yep.
and we can take a look at his project and discuss it with him. So, all right, and that's all the questions I'm seeing at the moment.
All right.
Randy asked another question, but Randy, you're getting into product questions that they don't fit this broadcast. This is not a product seminar. This is a technical seminar. So if you have product questions, I would email our product team at TradeWinds.
All right. Well, guess we got all the questions. Thank you all for participating in today's broadcast. And just a quick recap, the next Talking Comfort Live is March 11th. The next Tech 90 on FLEXX R32 installation, March 26th. And remember, at GREE,
Agree.
we're by your
We're
side.
by your side.